Vi is greater than 0. Vi is greater than 0. Positive half cycle. This one is positive half cycle of that sine wave is applied here. Greater than 0 means positive going half cycle. This one. This is the inverting op amp. Inverting amplification. At this point, the waveform is like that. Negative going signal. Negative going signal here. Due to this negative going signal, diode D1 is forward biased and diode D2 is reverse biased. Diode D1 is forward biased and diode D2 is reverse biased. Both the op amps A1 and A2 acts as an inverter shown in figure. In this case, both the op amps A1 and A2 act as inverter shown in figure below. Shown in figure below. D1 is on, that means short circuited here. This one is R. This one is R. Minus plus here. R VI. This one is connected to ground. R. D1 is short circuited means this point is connected here. Another end of R is connected to output of the A1. This one is A1. This R is connected to this one. This one is R. D2 is a reverse biased means open circuit. D2 is reverse biased means open circuit. Here 0 is there. Here 0. This one is R. D2 is off. D2 is off. D1 is on. D1 is on, short circuited. Minus plus R. This one is V naught like that. D2 is off. This one is A1. This one is a VN1, VP1. Here VP2, VN2. This VP2 means an inverting terminal of the A2 is connected to this resistance. One end of that resistance R, another end of that resistance is connected to ground. Therefore, simplified diagram is like that. Minus plus R VI. This one is R. This one is connected to ground. Another R. Negative, positive. And this one is connected R and ground here. That means there is no current flow through this R because IB2 plus is 0. This one is A1, this one is A2. IB2 plus is equal to 0. Therefore, it acts as short circuit. The drop across R is 0. It acts as short circuit. This one is V naught. This one is R. Find out the R for this case. This one is V naught dash. This one is inverting both the op amps A1 and A2 acts as inverter. Inverter 1, inverter 1 and inverter 2. V naught dash is equal to VI into this resistance by that is minus of that is equal to minus VI. Here output V naught is equal to output V naught is V naught dash into minus R by V naught dash minus 1. V naught dash is V naught dash is minus VI minus 1. That is equal to VI. V naught is equal to V naught is equal to VI. For V greater than for positive going off cycle, V naught is equal to VI. That means this one is VI. V naught is also like that. This one is V naught. Coming to second one, case 2. Case 2, for negative input, for negative input, that is VI less than 0, diode D1 is diode D1 is off, and D2 and D2 is on, and D2 is on. This is the circuit here. Case 2, here VI less than 0, that means a negative going off cycle. Here positive going off cycle is obtained here. For this positive going off cycle, diode D2 is forward biased, diode D2 is on, D1 is off. D1 is off. Therefore, simplified diagram is minus plus here, Vn1, Vi, R, D1 is D1 is on, and D1 is off. This one is off. Here D1 is off, D2 is on. D1 is off and D2 is on. Simplified diagram is like that. This R is connected to like that. Here the resistance is R here. The resistance R here. R plus R. Whenever this is open circuit, R and R is connected in series. Therefore, R plus R is 2R. Another op amp here connected to this one. This one is R. V naught here. Some R is connected here. From this point only, you have to connect here minus and plus. This plus VP2 is connected to this point. This point. This one is V naught. This is the simplified diagram. Here, this is the 0. This is also 0. From this point here, we have to the voltage at this point X. This one is X. This one is a Y. That voltage at the X point is V. Y point is also V. Y point is also V. Here, the current. This is connected. This point VN1, VP1. This one is VN2, VP2. Here VN1 is connected to ground due to virtual ground concept. Therefore, VA is applied to one end of that resistance or another one of that end of that resistance is connected to ground. This one is current. Some current is VI by R. Here also, this is the V volts. Let V is the voltage at X point, that is VN2. According to virtual ground concept, this is the 0. Vx is equal to Vy. At the Vy, that means Vp2 is also V. The current here is V by R. The current here is V by R. And here V is the voltage applied to this point. The current flow through this one is also V by 2R. V naught also. Here V by 2R. These are V by R. And this one is V by R. At this node, these three currents are, this is the I current, total current I from this output. At this node, these three currents are combined. This one, and this one, and this one. V by R plus V by 2R plus V by R is equal to 0. Therefore, find out V value. V by R is equal to V by R is equal to 2R. V plus minus minus of 2V. That is equal to minus 3V by 2R. R cancel. Therefore, V is equal to minus 2 by 3. V is equal to minus 2 by 3 VA. V is equal to minus 2 by 3. Here V is equal to minus 2 by 3 VA. V is equal to minus 2 by 3 A VA. This R, this is the R. Here R is there. R under 2R. 2R, another end is connected to ground. Here V is here minus 2 by 3 VI minus 2 by 3 VA. Minus 2 by 3 VA is connected to positive terminal of that op amp, second op amp A2, non-inverting terminal of the op amp. This one is entire one is the non-inverting amplifier configuration. Non-inverting amplifier configuration. Simplify this one into this one is A2. This voltage is V. V is equal to minus 2 by 3 VI. Minus 2 by 3 VI. This one is V naught. Some resistance R is there here. Some resistance R is there. This is the resistance R. This one is 2R. 2R, another end is connected to ground. 2R, another end is connected to ground. to R, another end is connected to ground. Therefore, this one is minus plus non-inverting op amp configuration. V naught is equal to 1 plus RF by R1 into V. 1 plus R1 by R by into V. 1 plus R1 is RF is R, R1 is 2R. V is equal to Vi is equal to minus 2 by 3 Vi. This one is minus 2 by 3 into Vi. V is minus 2 by 3 into Vi. Therefore, finally, 2R plus R, 3R by 2R minus 2 by 3 into Vi. 2 cancel, 3 cancel, RR is cancelled. V naught is equal to Vi. The circuit is also called as absolute value of the circuit. V naught here is Vi, absolute value of the circuit. The circuit is also called the circuit is also called an absolute value circuit. Absolute value circuit. And output is positive even when input is negative. Circuit as output is output is positive. As output is positive even when input is negative. Even when input is negative. Mod plus 2 suppose, and minus mod minus 2 is plus 2 only. Is plus 2 only. It is possible to obtain negative outputs for either polarity of input simply reversing the diodes. This one is waveform. This one is Vi, T, V naught. The waveform is like that. One, two, three, four. 1, 2, 3, 4. Input and output waveforms. Input and output waveforms. Input and output waveforms. With this, the analysis is completed.